In this second set of videos, we are going to use truth tables to determine the validity of an argument. So here we have an argument, P horseshoe Q, not P, therefore not Q. We begin with the first two columns filled in with our standard true, 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 false, false, true, false, false. And now we have to first fill in the next three columns, column 3, 4, and 5. So when P is true, not P is going to be false. When P is true, not P again will be false. When P is false, not P will be true. Then again, true down here. With not Q, looking over to Q, when Q is true, not Q will be false. When Q is false, not Q will be true. When Q is true, not Q will be false. And when Q is false, this will be true. And now for the fifth column, P horseshoe Q. When P is true and Q is true, P horseshoe Q will be true. When P is true, Q is false. P horseshoe Q will be false. And then when P is false and Q is true, by the paradox of material implication, P horseshoe Q is true. And the same in row D. When we have false, false, this will, by the paradox of material implication, be true. Now that we have our truth table completely filled out, we simply look at columns 5 and 3, because column 5 is the first premise, column 3 is the second premise. And we first look to find if there's any columns that are consistent with the validity. Well, the first premise is in row D. First premise is true, second premise is true, and the conclusion is true. But remember, to say that this is consistent with the validity does not prove that the argument is valid. It is quite possible to have true premises and a true conclusion with an invalid argument. How do we know that? Well, row C shows us. Because here the first premise is true, the second premise is true, but the conclusion, not Q, right over here, is false. So column C demonstrates that this argument is invalid. Thank you for listening. Bye.